Now, AMG is writing a new chapter. A new electric performance drivetrain.
It created such a smile in my face, unbelievable.
It's an unmistakable AMG. It has a lot of performance and it creates so much emotion.
While Tesla, Porsche, and Lucid were fighting over speed and range, Mercedes was building something no one saw coming. Not a car, but a motor. It's smaller, lighter, and stronger, and it might just scatter the competition. Stick around because the EV race just got tighter.
This is an axial-flux motor. A YASA axial-flux motor. It's an ultra-high performance electric vehicle motor, capable of taking you further and faster.
We have 3 completely new axial flux motors, 1 in the front, 2 at the rear, delivering over 1,000 kilowatts of peak power.
Mercedes-AMG is preparing to unleash a motor that is unlike anything currently powering an electric car. Built by the British engineering firm YASA, which is now fully owned by Mercedes, this next-generation electric motor produces 737 horsepower and weighs just 13.1 kilograms or 29 pounds. The power-to-weight ratio is staggering, 42 kilowatts per kilogram, a level of performance that until now hasn't existed outside of laboratory concepts or high-end aerospace systems.
They are ultra compact and can hit speeds of more than 360 kilometers an hour or more than 225 miles at top speed.
This isn't just about raw power, it's about how efficiently that power is delivered and what it means for the future of electric vehicle design. The secret lies in axial flux technology, a motor layout fundamentally different from the radial flux motors found in nearly every EV today, including Tesla and Lucid. In a radial flux motor, electromagnetic force flows outward from the center of a rotating cylinder. That design works, but is bulky and leaves efficiency gaps. The axial flux motor flips the layout. Its rotors and stator sit in a stacked disc-shaped setup where electromagnetic force flows across the face of the motor, not around its sides. This lets it generate more torque in a smaller, flatter, and lighter package. In simple terms, you get more output with less material and less space. That's not theoretical. Mercedes' prototype weighs less than most performance braking systems, yet it matches or exceeds the output of much larger electric motors. It's compact enough to fit in spaces previously unusable for drive units and light enough to reduce overall vehicle weight in ways that affect everything from acceleration to steering feel. For years, axial flux motors were considered too difficult to scale. They worked in theory, but most automakers avoided them due to manufacturing complexity and cooling challenges. Mercedes, through YASA, appears to have solved those issues. According to YASA's Chief Technology Officer Tim Woolmer, the 737 horsepower prototype uses standard silicon steel and oil cooling, not exotic materials or genius manufacturing tricks. Their target is 10,000 to 50,000 units per year.
This is the concept AMG GT XX. Call it pioneering technology program, call it concept car. One thing is for sure, this takes AMG performance to a whole new level.
This technology isn't being developed in isolation. It's already integrated into the design of Mercedes-AMG's upcoming electric performance platform, known as AMG.EA. The first public demonstration came in the concept AMG GT XX, a 4-door electric concept that uses 3 axial flux motors, 1 in front, 2 in the rear, to produce a combined 1,341 horsepower and a top speed over 360 kilometers per hour or 223 miles per hour. That car isn't just for show. Mercedes confirmed that production versions based on the GT 2020 concept are already in development and will begin rolling out from 2026 onward. The axial flux motor isn't a science experiment, it's part of Mercedes' next generation product plan. Why does all this matter? Because an EV's motor isn't just a power source, it's a structural and thermal support for the entire vehicle. The smaller and lighter the motor, the more flexibility engineers have. With this setup, Mercedes can shift weight lower, remove unnecessary cooling components, and open up the chassis for better aerodynamics, suspension geometry, or battery packaging. That means better performance without trade-offs. From a driving perspective, this means faster throttle response, improved efficiency, and better balance. From a manufacturing viewpoint, it reduces the number of components and simplifies integration. And strategically speaking, it gives Mercedes-AMG a distinct performance edge, something no mainstream automaker currently offers. Mercedes isn't alone in researching axial flux tech, but they are ahead in implementation. The Oxford-based YASA facility is already equipped to produce tens of thousands of motors annually. Production lines are being developed with scalability in mind, and testing is ongoing. This isn't a boutique technology, it's being industrialized. Tim Woolmer called the motor a step change in EV performance, and that's not an exaggeration. Automotive World echoed this potential, noting that axial flux motors are positioned to transform performance EVs by unlocking power-to-weight ratios never seen before in production cars. The industry has long chased range and acceleration. Now Mercedes is showing that efficiency and compactness could be the blueprint in the years ahead. Of course, this motor isn't in a production car yet, but it's not locked in a lab either. It's fully built, running, tested, and integrated into next-gen prototypes. The factory tooling is underway. The first wave of AMG electric models featuring axial flux propulsion is closer than most expect. And here's where it gets interesting. Mercedes may own YASA, but it is not the only ones tapping into this technology. Even after the 2021 acquisition, YASA confirmed it would continue supplying motors to third-party automakers. And they didn't mean low-volume niche builders. We're talking about Ferrari, Lamborghini, and McLaren, brands that demand only peak performance. Ferrari, for example, uses a YASA axial flux motor in its SF90 Stradale hybrid, where the motor helps power the front axle with immediate torque and ultralight packaging. McLaren and Lamborghini have similarly leaned on YASA for electrified drivetrains in upcoming supercar platforms. So the axial flux motor is here, but what were automakers using before? It's worth understanding what's under the hood of most EVs today. The radial flux motor. This is the default electric motor layout used in almost every mainstream electric car on the road right now. In a radial flux motor, the magnetic field moves outward from the center like the spokes of a wheel. The rotor spins inside a cylindrical stator, and the force flows in a radial direction, hence the name. It's a tried and tested design. It's compact, reliable, and relatively cheap to mass produce. But it also has limitations. The layout takes up more space, especially in terms of diameter and length. It generates a lot of heat, which requires complex cooling systems. And because the magnetic path is longer, squeezing more power out of the same volume is harder. That's why even the best radial flux motors, like those used by Tesla or Lucid, still face a trade-off between power, weight, and thermal efficiency. They're not bad. They've taken EVs to amazing levels of performance, but they're reaching their peak, and that's where things start to get interesting.
In the competitive world of Chinese electric vehicles
looking for a spot
that are going further and costing less than ever before, no company makes or sells more than BYD.
We wanted to really show that an electric car could be the highest performance car in the world.
In the electric performance space, 4 names keep circling the top: Tesla, Porsche, Lucid, and increasingly BYD. Each is chasing dominance, but with very different priorities, platforms, and technologies under the hood. Tesla still owns the headline-grabbing numbers. The Model S Plaid remains the fastest production EV when it comes to raw acceleration, boasting a 0 to 60 time of just 1.99 seconds and a tri-motor setup producing up to 1,020 horsepower. Its motors use carbon-sleeved rotors to improve thermal tolerance and rotational speed, and they've proven consistent at high power. But there's a trade-off. The system relies on radial flux motors, which are relatively bulky. Each one weighs upward of 70 to 80 kilograms, especially with Tesla's advanced cooling and inverter systems packed around them. Tesla's real strength lies in its integration battery, software, and drivetrain all optimized together. But when it comes to motor design itself, they're refining rather than reinventing. There's no radical packaging breakthrough here, just powerful motors housed in a traditional EV chassis. Porsche, on the other hand, doesn't chase acceleration headlines. It focuses on repeatable, track-validated performance. The Taycan Turbo S isn't as quick as the Plaid in a straight line, but on a circuit, its dual permanent magnet motors shine. Porsche designed them for thermal durability, with a unique hairpin winding design and oil-cooled stators to ensure they hold up under continuous load. But Porsche's design remains conservative in form. The Taycan's motors are compact, yes, but still built around radial flux layouts. They're efficient and reliable, but space and weight is restricted by the traditional motor architecture and battery layout. Porsche hasn't yet made a leap into compact high-density motors or restructured packaging in a meaningful way. Instead, they've mastered consistency over innovation. Lucid Motors, meanwhile, has quietly become the benchmark in motor efficiency. Its proprietary electric drive units are among the smallest and lightest in the industry, just 74 kilograms for a complete motor, inverter, and gearbox that puts out 670 horsepower. That's under 11 kilograms per 100 horsepower, a number that's caught the attention of both engineers and investors. Lucid's axial length is minimal, and their in-house permanent magnet motors are known for incredibly high efficiency, up to 4.6 miles per kilowatt hour in real-world use. Lucid isn't just fast, it's efficient. The AirDream Edition delivers over 1,111 horsepower and still pushes beyond 500 miles of range. And while their motors are compact and brilliantly engineered, they're still using radial flux just miniaturized to an extreme level. Lucid is refining the concept better than almost anyone, but not rewriting it. And then there's BED, the unexpected powerhouse. Long focused on mass-market electrification in China, BYD is increasingly leaning into performance EVs, especially with its Yangwang U9 supercar. That model uses 4 electric motors, one at each wheel, to deliver over 1,200 horsepower and advanced torque output. Their YASA quad-motor architecture claims 0 to 60 in under 2 seconds, and BYD has developed its own inverters and blade battery system for improved structural efficiency. While BYD's hardware is impressive, its motors are still conventional. There's no axial flux transformation here. Instead, BYD's performance edge comes from system-level integration, like combining power delivery, traction control, and body motion management into one system. In some ways, they're trying to do what Tesla did 5 years ago, beat competition through software mastery, not mechanical revolution. And so it begs the question, who will come on top at the end of it all?
The auto world is charged up this morning after a dramatic presentation by Tesla Motors. The electric car company announced a new version of its original model. Carter Evans talked to Tesla's CEO, who wants drivers to go really, really fast.
The EV arms race isn't just about motors or battery cells. It's about who's better positioned to evolve, who can actually take breakthrough technology like axial flux motors and turn it into a winning car at scale for a market that moves fast. On one side, you've got the legacy giants, Mercedes and Porsche, brands built on decades of engineering discipline, global infrastructure, and deep R&D budgets. Mercedes, for example, didn't just buy YASA to sit on it. They're building full-scale production facilities in the UK. They've developed an entire electric architecture, AMG.EA, specifically designed to house and exploit the axial flux motor's strengths. This isn't a side project, it's a full system pivot backed by institutional muscle. Porsche operates a bit differently. They've made it clear their loyalty is to consistency. The Taycan wasn't a moonshot, it was a surgical strike. High repeatable performance, cooling systems tested on the Nürburgring, and motors that perform lap after lap. Porsche doesn't rush, but they also don't rebuild from scratch easily. While their motors are excellent, the platform remains conservative. If axial flux becomes the next big thing, Porsche may have to play catch up unless it shifts gears fast. Then you have the upstarts, Tesla, Lucid, and BYD. Tesla isn't new anymore, but it still moves like a startup. When it sees a performance edge, it builds it. When it sees manufacturing pain, it goes around it. Here's the thing, Tesla has been refining the same basic architecture for years. The Plaid's motors, while powerful, are still variations on the original S platform. Elon's team is brilliant at squeezing efficiency out of existing ideas, but if a new motor layout changes the rules entirely, Tesla will need to act fast or risk being outflanked.
Meanwhile, Phil LeBeau is here. Shares of EV maker Lucid are down sharply with its lockup period expiring today, but the rest of the EV space is performing well. Phil has those details.
Mike, yeah, when you look at the EV stocks, this is a Lucid issue, and we're also going to talk about Workhorse in just a little bit.
Lucid has arguably the most advanced radial motors on the road today. They're small, light, and brutally efficient. But Lucid is still young. They don't have Mercedes' global footprint or the production muscle of BYD. Every new model is a moonshot. Every supply chain delay matters. They've proven their tech works. Now they have to prove they can scale it fast while watching other players catch up. And then there's BYD, the wild card. They're chasing total control. BYD builds its own batteries, designs its own chips, and manufactures cars at scale that rival Tesla in volume. Their quad-motor Yangwang U9 proves they can do performance when they want to, but their motors are still radial, and their systems, while smart, aren't built around bleeding-edge weight reduction or axial packaging. Their edge is vertical integration. If they decide to chase something, they can spin up factories to do it tomorrow. So there you have it. Mercedes-Benz wants to change the game. Do you think the axial systems will revolutionize EVs?